Okay, hello guys. Today we are talking about the harder stationary points. Okay, that's moving to the first part of it. So here you can find that we have the notation of it. So we already said like the differentiation can be written down as the f(x) here is a dot right here. So if you want to represent it for the second derivative, or you can also say like d squared y over dx squared, or like here we can written that as f2 differentiation symbol here. Okay, so that is basic symbols of this. Okay. So then we can just go into the example. Like here, if you want to find the coordinate of stationary point, okay, so the point stationary point is called that the differentiation of the point exactly equals to the zero. Okay, so we can say the fx differentiation equals to 6x minus 3x squared. Okay, that is exactly what the differentiation here. Okay, and we can say that when it equals to zero, so you can just consider like a peak, like here. It is, or this means a stationary point, okay? So we can say like, or you can also consider as a turning point. Like this turning point, make sure that the gradient just change inversely, okay? That is a two point. So we can say here that is x or 3x2 minus x equal to 0, right? So we can say the final answer, x can be chosen as 0 or x can be chosen as 2, right? So we have the two stationary point here, okay? So also remember that the point has to chosen both x value and y value. So 0t is not enough, so we have to just chosen the to set y coordinate as well. So we can say the f0 equals to 3 times 0 squared minus 0 cube equals to 0. And f2 equals to 3 times 2 squared minus 2 cube. It equals to the like 4 times 3 4 times 3 and then minus 8. Okay, so that is 12 minus 8 equals to exactly 4. Okay, so here is for 12 minus 8 equals to 4. Okay, so also like here you can find the solutions here. Just consider like or just last through the differentiation equal to 0. Okay. So here you can find this graph. You can find 3x squared minus x2. Here we have 2.00 and 2.4. You can find that the differentiation both equals to 0, right? You can find the blue line, that they're horizontal to x-axis, right? Okay. And also we can find that just calculating the secondary differentiation, you can find the secondary differentiation at 0, it equals to 6, and the secondary differentiation at 2 equals to negative 6, okay? So here we can just consider like here, because this is the secondary differentiation bigger than 0, so that is the minimum point, and this is the secondary differentiation that is the maximum point, smaller than 0, maximum. So maybe I have a question. So, teacher Mai Lin, why you have here like the secondary differentiation bigger than 0, but it's a minimum point? So let's consider here, like if you're just trying to draw the differentiation graph here. So at the left side of the differentiation, or at the left side of 0, you can find the differentiation equals to a negative value, right? So here is a negative value. And then at this point, exactly equals to 0, right? So this is 0. And on the right side, you can find here, exactly is bigger than 0, right? So it's just moving upwards. So you can find here, that is a graph for f(x) differentiation. So you can find f(x) differentiation is bigger than 0, right? So we can say that the f(x) secondary differentiation is bigger than 0, okay? That is it. And also you can find here, like in this point, we can find on the left side, you can find the differentiation is bigger than 0, right? You can just try to draw the differentiation graph. And on the right side, you can find the differentiation is smaller than 0. So you can also just, you just follow and just like draw the graph totally. Okay, so here it is. So you can find the differentiation is smaller than 0, right? So we can say that this maximum point has a secondary differentiation and is smaller than 0, right? Okay, that is it. Okay, so like here we can just like for the differentiation, for the point like dy over dx, it may equal to 0. That means a stationary point. But if you want to determine whether it's a maximum or minimum point, we can say like maximum point has to make sure that the secondary differentiation smaller than 0, and the minimum point has to make sure that the secondary differentiation is bigger than 0. Okay, that is a stationary point differentiation here, different here. Okay. So here's the example here, like that looks through together. Like for fx equals to x plus 1 over x distinguish between the maximum and minimum, right? So first, we can just try to draw the differentiation graph here. The fx differentiation can be considered as 1 minus 1 over x squared, right? That is it. And then we can set for this differentiation, just like make sure that 1 minus 1 over x squared equals to 0, right? So here we have x equals to 1 or -1, right? So just to make sure which is maximum or which is minimum, so you have to just make sure to calculate the secondary differentiation, that is 2 over x cubed, right? So when x equals to 1, it is smaller, it's bigger than 0, right? So that is a minimum point, right? And this just trying to calculate the secondary differentiation, that is 92 is smaller than 0, right? So that is a maximum point. So just put through or just let x equals to 1 and x equals to -1 into the function, right? So when x equals to 1, f1 equals to 2, and here f-1 equals to -2. So that is a maximum point, and here's a minimum point here, okay? That is it. Okay, so that is solutions here, and I guess it's all very difficult, right? Okay, so that's for today's our lesson. Hope you can truly understanding for about the stationary point, and they're very important for you. Okay, so that's all. See you next time. Bye.